Good morning, 7th grade mathematicians. I bet you did not expect to hear from me today. By now, Tanner has handed out the Unit 7 Lesson 5 homework to you and collected the Unit 7 Lesson 4 homework that was due this morning. Now that you've done that homework and we've done the lesson from the past few days, I think you're ready for this homework. The very first problem, I'm not even going to demonstrate for you. Tanner's going to put this video on pause for just a couple of minutes and let you work this problem. I bet you can work it in less than 2 minutes. All right. I am going to demonstrate this second problem now, though. It's a little bit more challenging. It took me a minute to figure out how to solve this. We're trying to find angles X and W. Why don't you take a look at this for just a minute and see if you can make some connections and figure out at least one of the angles. Go ahead. All right, I'm looking at this and I bet you've already figured out that this is 90 degrees. I mean, they tell us that L is perpendicular to M. And by the definition of the word perpendicular, we know that we have a 90-degree angle here and a 90-degree angle here. So we are told that this right here is a 138-degree angle. And we have been talking a lot about the vertical line theory. So we know that the angle that is vertical, the vertical angle theory, the angle that is vertical to this one is this angle right here, right? Because this line and this line form these two opposing angles. So if this is 138, we know this also is 138. All right, we can right away take 90 degrees out of this 138-degree angle. And I'm going to do that right now. If I have 138 degrees and I subtract 90, you guys have your calculators out? Take a minute to grab a calculator right now if you don't have one. All right, 138 minus 90 is, there we have it, 48 degrees. Now, I think this illustration is not put together exactly correctly. I think they wanted to avoid giving this away. So they drew it slightly incorrectly. But this part right here is 48 degrees, according to our calculation. So armed with that information, we can take 19 away from this 48, and we'll be left with angle X. Pull out your calculators and crunch that number for us. What do you get? I got 29. 29 right here. So X equals 29 degrees, right? And that leaves us W. This isn't going to be too hard to figure out. We already have 48 degrees here. We know this entire angle is a 90-degree angle. So we just need to subtract 48 from 90 and we'll have that. So I'm going to do that. What'd you get? Did anybody do mental math to come up with this? Oh, hopefully you entered your numbers better than I did. All right, I got 42. See? So, angle W is 42 degrees. Does that add up? Let's see, we should be able to add 90 plus 48 plus 42, and what will we get? We should get 180 degrees. Let's do that. 90 plus 48 plus 42. There we have it. 180 degrees. We're done. Why don't you pause the video and try number 3 on your own for just a couple of minutes, and then we'll resume with problem 4 in just a minute. Go ahead. All right, problem 4 is actually a collection of problems, and we're doing some review of your favorite topic, inequalities. How many are there? Look at that, there's only 3. In fact, there's only 3, and I'm going to do one of them with you. The first one, just to refresh our memories on how to do this. I see that we have 2 factors here. That means 2 parts that are being multiplied together. And how can we multiply these 2 pieces together? Anybody know what the word is? What is it when we do that? That's right, it's distribution. So I'm going to rewrite this problem distributed. It'll be minus 24 is greater than minus 6 times x. That's negative 6x, right? And then it's going to be minus, I know some of you don't like it when I say minus instead of negative, so we're going to say minus negative 6 times negative 5. Well, we have a negative times a negative, so that's going to be a positive, huh? Changing that to a positive. So negative 6 times negative 5, negative 0.5, I'm sorry, is going to be half of negative 3, or negative 6, which will leave us at 3. Is that right? Negative 6 times negative 0.5 is positive 3. Now we know what we need to do. We need to get rid of the riffraff. This is riffraff. It's positive 3. We can add negative 3 to it, and we get 0, right? I'm just going to cross that off. Because we did it to this side, we need to do it to this side. We subtracted 3, we're subtracting 3. And what do we have? We have a negative 27. Is my math right so far? Hopefully. Okay, is greater than negative 6x. That's what we're left with. Now we want this x, we're solving for x, we want it to be by itself. We do not want that negative 6 to be there, so what are we going to do? We're going to multiply by the multiplicative inverse, which would be 1 over negative 6, or Sophia finds that to be a clunky approach, so I'm going to do it her way. We're just going to divide by negative 6. Because we did it on this side, of course we have to do it on this side too. So this just cancels out and we're left with the x. Negative 27 divided by negative 6, well, it's going to be a positive, and I know we can put 3 into this 29, or into this 27, and we will get 9, negative 9, and we can put 3 into this negative 6, or divide this negative 6 by 3, and we're left with negative 2. So I'm going to get rid of those negatives. They cancel each other out. We can say, oh, what do we do with the sign? Did we divide by a negative? We sure did. So what we're going to say over here is that, because I'm running out of space, 9 halves is less than, because we flipped the sign since we divided by a negative, x. Alright? You solve the next one. In fact, you solve the next couple. I'm going to ask Tanner to pause this video. Alright, I'm moving on and catching up with you guys. Alright, I felt like this problem 5 was challenging, so let's work it together. A runner ran 2/3 of a 5-kilometer race in 21 minutes. They ran the entire race at a constant speed, and I'm telling you, in real life, we're probably not going to run at a constant speed, but this is math book world. Things can be constant. Okay. How long did it take to run the entire race? Well, we can look at this as the guy or gal is running 2/3 of 5 kilometers per 21 minutes. It's sort of like saying miles per hour, only it's kilometers per 21 minutes. So I could write it this way. 2/3 of 5 kilometers is 2/3 times 5 kilometers per 21 minutes. And we're trying to figure out how long it took to run the entire race. Well, we know how long it took to run 2/3 of it. So how long would it take to run 5 kilometers, the entire race? That would be actually one whole race times 5, which is 5. Okay, so how many minutes? I'm going to use cross multiplication because it's going to work really handily here. I'm going to multiply 21 by 5. In fact, let's just get rid of that one. It's useless. 21 times 5, that's going to give us, mental math here, 105. And then we're going to divide that 105 by whatever this is. So let's just remember 105. I'm going to put it up here so I don't forget what it is. And I'm going to figure out what this is. 2/3 times 5. 2/3 times 5 is going to be actually 10/3, right? That's 10/3. So I'm going to divide 105 by 10/3. Now, we know that we can keep it, switch it, flip it to divide by a fraction, right? So I'm going to take 105 and divide it by 10/3, which means I'm really going to multiply it by 3/10. So I'm going to get, mental math here, 315 is what 105 times 3 is. 315 tenths. So I think if I simplify this down, I want to get rid of that, right? Turn it into a 1. To do that, I need to move my decimal point over here. I don't know if you guys have had that lesson yet, but I have just divided 315 by 10 simply by changing the position of my decimal point. So basically what we know is that we can run 5 kilometers in 31.5 minutes. All right, so the next question is, I should write the answer down. It took 31.5 minutes to run the entire race. Should we check that before we move on? How are we going to check that? Well, we could divide 5 by 31.5 and see if it winds up being the same as this divided by 21. Doesn't sound too easy, but it doesn't sound too hard. Let's just do it. 5 divided by 31.5 equals, that's a messy number. It equals 0.159. It doesn't exactly equal it. Almost equals it. So let's crunch this one real quick. You want to do it? Go ahead. Pause the video for just a second and see if you can enter this into your calculator correctly. All right, I'm going to do it too. So I'm going to enter it this way. I'm going to put a parenthesis. My camera goes out of focus. I'm going to put the calculator over here, because my camera just doesn't focus very well over here. So I'm going to take 2 and divide it by 3 and multiply that by 5 and see what I get. And then I'm going to divide that by 21 and see what I get. And look at that. I got the same thing. It's, again, almost 0.159. All right, so I think we got it. 31.5 minutes. The next question is, how many minutes did it take to run 1 kilometer? If it took that many minutes to run 2/3 of 5 and that many minutes to run 5 kilometers, how many minutes did it take to run 1 kilometer? Well, I think that we could say 31.5 divided by 5, because we've got 5 kilometers in 31.5 minutes. 5 kilometers, you know, bunch of minutes. Here's my minutes, 31.5 of them. If I divide it into 5 pieces, that will be 1 kilometer, right? So let's just do it. 31.5 divided by 5. I get 6.3 minutes. Erase my little visual. My answer is 6.3 minutes. Hopefully you figured that out ahead of me and you're just finding that I agree with you. The next problem, I'm going to have you work on that one by yourself because they've done such a great job of visualizing it. Basically, you can tell right here. You've got 3 M's, you've got 2 4's, you've got 1 2. Add it all together, you're going to get 37. So see if you can turn that into an equation. go ahead and pause the video. All right. I'm going to demonstrate just one of these, just so you remember how to look at potentially equivalent expressions. Here's my original expression. Which of these are equivalent to it? Am I going to get this if I take 9 out of each one of these terms? Actually, they're taking a negative 9. Let's see what happens when we take a negative 9 out of this. See if our math agrees with their math. I'm going to take negative 9, and negative 9 times a positive equals 36x. So I'm agreeing with them that 4x works. Negative 9 times a negative is going to give us a positive 54, so negative 6y, and that agrees with them. Negative 9 times a positive is going to give us 90, so negative 9 times positive 10 is going to give us 90, and that actually does not agree with them, so we're not going to choose that one. Go ahead and work the rest of these. Try to factor out the same thing that they factored out and see if this is the expression, the rest of the expression, the rest of the, if this is a product that matches your ideas. Good luck.